Here we go, we're live. Welcome to GCP Online Meetup number 28. Today we're going to be talking about Google Cloud Storage, and my name is Anthony Bouchon, and I'm a customer engineer based out of San Francisco. But I have the great fortune today of being joined by our friends in the East Coast. So, Mike, you wanna tell us what we have in store today?
Yeah, absolutely, Anthony, and thanks for having us. I'm Mike Cornesto. I'm a cloud customer engineer in the Reston office, and I'll be the host. And Roman Harkovsky, who's also a cloud customer engineer in the Pittsburgh office, will be presenting, and we're going to be talking about Google Cloud Storage and good bit of detail about the offering, and then some, several different use cases. So, Roman, over to you.
Thank you, Mike. Good morning or good afternoon, everyone. So today we wanted to talk about the Google Cloud Storage. You could see the replay of this recording later if you have to jump off in the middle. It will be posted on online meetups. So we'll discuss about several things about Google Cloud Storage, what it is, and the use cases when you use it. So both Mike and I are on the same team. I'm in Pittsburgh, Pennsylvania. Mike is in Virginia. So we're cloud customer engineers. What that means is we work with our customers and we help them understand and start using Google Cloud Platform. So we'll also do some demos today and discuss use cases and discuss migration scenario. How do you get started with Google Cloud Storage, which I hope you will after listening to this presentation. Now, for those of you who are not familiar with object storage, and Google Cloud Storage is one of the examples of object storage implementation. So the object storage is quite different from your traditional on-prem storages, because normally if you're running your workloads on-prem, you probably are very used to using SQL databases or maybe NoSQL databases, and for that you would use either JDBC or some other connection to the database to work with somewhat structured data. It could be JSON data, SQL data. If you are using file systems, then you have your program using the file system interface, navigating the hierarchical storage. So object storage is different. Object storage is designed to store blobs of data. It doesn't really care what's inside of the blobs, but it makes it easy to get access to the data. It could be locally or it could be remote over the internet. So the whole point of this is that you can make use of it in many, many different ways, and it's surprisingly versatile. Now, the Google Cloud Storage implementation is very advanced. We have several very strong security features. For example, automatic encryption at rest. So whenever we store your data somewhere in the deep storage facilities in Google Cloud Platform, we always encrypt that data, and we can manage the keys for you, or we can let you manage your own keys if you'd like. We also have identity integration and access management. We have access control lists, so you can define who can and who cannot access that storage. We have Forseti security integration, which is an open source framework that we just recently released together with Spotify, and that could do enforcement of your security policies. So for instance, you could say that not a single object can have public URL in your storage, and then that Forseti will periodically scan your storage, and it will find all of the violations and then automatically enforce them if necessary. So it's an open source framework, and you can use it for many different things within Google Cloud Platform, including for enforcing cloud storage security. The GCS is very high performance. We'll talk about that later, and it has several interesting things like object versioning, for example. So you could say, whenever I update my object or I add a new object or I delete it, you can keep a full history or limited history of these objects. So you never overwrite an existing object if you don't want to. Another thing we have is a lifecycle policy. We'll talk about different storage classes. So you can define policy where we'll automatically move the object from the hot storage to colder storage based on the time that it's been sitting in that storage and some other policies. Another really interesting feature is change notifications. So whenever somebody deletes, updates, or adds a new object, you can attach notification, and it's a programmatic sign that will invoke your Google Cloud function And in the Google Cloud function, you can write JavaScript and do whatever processing necessary. So for example, if you have, let's say, some batch workload where maybe credit card transactions are being passed around as, let's say, CSV files perhaps, or whatever other data, it could be some other medical data, you can create those notifications for every new object that shows up in Google Cloud Storage. You can pass it along into some other processing, for example, into data flow, where you could do your own processing, and you can modify and update that data. You can also edit object metadata, which could be very useful for a number of different things. Obviously, we have logging for administrative purposes, who accessed what data. And nice, interesting thing is that, so you probably understand by now that Google Cloud Storage competes with Amazon AWS S3 and Azure Blob Storage. And what we have is XML API that is compatible with S3. So if you have an existing system and it's using S3 today, you can switch to Google Cloud Storage without having to rewrite your application because of that compatibility layer. And last not least, we provide a low-cost solution for storage.
Hey, Roman, great summary. You covered a lot of ground there, and probably folks will want to go look at documentation and learn more. But I think price is always of interest. So let's have a look at that, and what can you say?
Yeah, so price is always changing, and what we've done, we've worked very, very hard to drop down the cost of storage as well as compute. In this case, you could see that over the last several years, we were able to drive the cost of storage roughly about 96% down from what we've had back in January 2011. So that's a very dramatic decrease in storage. So imagine from 17 cents per gigabyte per month down to 0.7 cents per gigabyte per month. So you could see this is very exciting, and it makes it only so much more compelling to start using that. Speaking of the classes of storage, I already mentioned that we have several different classes of storage. So there, on the top, you could see multi-regional, regional, nearline, and cold line. So what they are is, one thing to know is that on top, you see there are several different things that are quite unique about Google Cloud Storage. So one of them is that all of these classes of storage, they provide consistent API. So if you have your program using Google Cloud Storage API, you don't have to change anything in your code to switch that to use, for instance, cold line or multi-regional or regional. The API is consistent. That's a really good news for application developers. The second thing is that the performance across all of these tiers is consistent. And you might think, well, how is that even possible that the cold line could be the same performance as a hot line, as multi-regional, and I'm still paying differently or not, and what is different? So what you see on the bottom of this table is the first byte read latency is lower digit milliseconds for any class of storage. So that makes that time to first byte pretty much the same for regardless of the class of storage. But the cost is different. So multi-regional, what the difference between multi-regional and regional is that you get your data replicated across multiple data centers, we call them regions, across the globe. So if you have a website that you do music streaming or image distribution or whatever content distribution, with multi-regional, first you have higher availability, and then you can connect it to CDN so that it lives closer to your user location. Now with regional, it costs less, 2 cents versus 2.6 cents compared to multi-regional, but it only sits within a single region. It is replicated between zones within a region, so it is still highly available, but it's not replicated across multiple regions. So if the disaster strikes that particular region and the entire region with all of its zones goes down, then that data will not be available for a while. So that might be a reason to use multi-regional. Nearline has lower cost than regional. Is exactly half the cost, 1 cent per gigabyte per month. But Unlike regional and multi-regional, now with nearline and codeline, you also have data retrieval fees. So what that means is that nearline is usually a good choice when you expect to not access your data more than once a month because of the data retrieval fees. And then there's a minimum storage duration of 30 days. So in other words, with multi-regional and regional, once you store the data, we start counting how much it costs to store the data. But if you delete the data, you don't pay for it. With Nearline, the minimum storage duration of an object is 30 days, even if you delete it. With Coldline, it's 90 days. And then you also pay progressively more for data retrieval. Now, if data lives in the cloud and your consumer of that data is outside of the cloud, then you still pay network egress fee. In other words, the traffic that comes out of the cloud into your end users. So that's true for any class of storage, and it's true for any cloud providers. There is always data egress fee. However, let's say machine learning on that particular data, and your machine learning runs within the same region or zone where your data lives. For regional and multi-regional, there is no data retrieval fee because there is no traffic leaving the cloud. For nearline and coldline, there is some. Now, there's also availability. Now, because multi-regional is replicated, you see that SLA for availability is 99.95%. The SLA for regional is 99.9, and then nearline and coldline both 99%. So that's availability. Now, the durability is 11 nines. So what does it really mean to have 11 nines durability? Now, to put it in simple terms, it basically means if you have 10,000 objects that you put in a storage with 11 nines durability, you can expect to lose one object out of those 10,000 in 10 million years. So if that's not good enough for your durability, you may want to replicate that even more. But for most workloads, that's probably enough. And object sizes could be anywhere from a single byte up to 5 terabytes per single object. So you could have pretty much any number of objects, petabytes and petabytes, or even exabytes in total, but any single object can only be as large as 5 terabytes. So.
Great, great, Ron. That's a great summary. Now you're talking regional, multi-regional. How's all this data transferred, and what are some of the things that Google brings into play there?
Yeah, so one of the things that not many people know is that Google owns one of the largest networks in the world, and we have Trans-Pacific and transatlantic cables that we own. And whenever data moves between Google regions or between the region and your end users, it is moving over Google-owned network. What that means is it provides higher security, and it's not as dependent on whatever is going on a usual internet shared network at the time. And it also provides lower latency. So that makes it great for latency sensitive applications and for managing the network. And then if you talk about compute, we can also do some very unique things like sharing IP address spaces across multiple regions and many other things that other cloud providers cannot do. And it also comes handy when we start talking about specific use cases, for example, for media, distributing the media, streaming that media, delivering the content, HTML, images, and so forth. They will be flowing over this network, and we have many points of presence, over 100, and that is one of the unique differentiators for Google Cloud. And speaking of performance, so we had our partner who tested the Fastly. They tested the latency of Google Cloud Storage from the East region as well as S3 in the East region, AWS S3. What they found is that you could see on the right-hand side that GCS latency was roughly 3 to 4 milliseconds, where the S3 latency was about 220 milliseconds. So that's a very significant time to first byte. And when you have a user application, obviously, the lower the latency, the better, because you want users to start seeing content as soon as possible. You can see full presentation at this URL that I have here. So I just wanted to show you a quick demo. We kind of went over what the Google Cloud Storage is. Just wanted to give you a feel how to use it from an administrator perspective, and then we'll talk about how do end users consume that. So what I have here is Google Cloud console. And in the console, I can open multiple different services. And one of these services is storage. So let me open storage. And I already have several buckets. And you can see that I created multiple different buckets. Some of them are cold line, airline, regional. And when I was creating them, I used different location. So let me create a new bucket. Let's call it demo. And let's just make it regional bucket, and we can pick the data center location, for instance, US East. We could specify labels, and those labels could be like production environment as a test environment, and so forth. So I'm creating my bucket, and for now, when I just created the bucket, it's empty. So now I can upload files, and the objects are initially files. And you could see that I can have all kinds of different files. Obviously, anything can be stored. And those are puppy images, those are CSVs, the JavaScript, it could be HTML. Depending on the use case, you will be storing different kind of data. And when I click upload, it uploads all of those images. And now, since I'm authenticated through my browser, you could see that nobody else can access this data unless I give them permission. So I can click on an image and it will open an image of the puppy in this case, or I can open CSS or JPEG. But I can also make these images available publicly. So for instance, I could say, I want this to be available, click, and there is a public link. So if I click on the public link, it will open that image. And then now, for those of you watching the webcast, if you type in this URL, you now are going to be able to access that image as well. Now, if I uncheck that link, that image will no longer be available. And I can also edit permissions for my object. So it could be bucket level permission, it could be object level permission. I can edit metadata for my object. I can add custom metadata. So there are all kinds of things. I can move it and configure different policies for the data. And I can also, like I mentioned, we have S3 interoperability API. So I can enable that API for S3 as well. All right.
Great, Roman. Great whirlwind tour. Now you're showing the console, but obviously programmatically, there's got to be some other ways to do this. Can you talk a bit about other ways to access the data?
Yeah, sure. And Mike, by the way, there's a little bit of a background noise. I don't know if you want to use mute.
Oh, great! I can do that. Yep.
Yeah. Thank you. So I just showed you one of the ways to access the GCS, and that was using authenticated browser, right? Now, there are other ways to do it. So there's a command line. When you install Google Cloud Platform SDK, you could use gsutil command line where you can create buckets, create objects, move buckets around, change permissions, and you can use it in your shell script. There are two other ways. There's XML API, and the XML API is S3 compatible, and there's also JSON API. So you can access the data, upload images, download images, change them, and work with them using these APIs. There's also public HTTP access. That's when I click that I want to enable this file or object to be available for the public, so I can use that. And you could use it for public websites. I can also create signed URLs. So for instance, I might have some data in the storage where I want to share that with a group of people for a period of time. I can put expiration time, and then I can encrypt that URL, and then I can share the URL with the signature and expiration timestamp. And only those people who have that link will be able to open and download the object. And then after the expiration time, they will no longer have that ability. And finally, we talked about authenticated browser. Finally, in the BigQuery and Dataproc on Google Cloud Platform, you can replace Hadoop with Google Cloud Storage. So we'll talk about that a little bit later. Okay. So now that we discussed some of the basic capabilities, how can you move your data to GCS? So this is a really, could be a really complicated question, because depending on the amount of data, so you see on the y-axis, I have, oops, there's a lot of background noise over there. Thank you. So on the y-axis, you see the size of the data that you might have. So let's just imagine 10 terabytes of data that you may need to transfer. On the x-axis, you see the bandwidth. So if you have 10 gigabit per second connection, it will take you roughly 3 hours to transfer 10 petabytes of data. And then you could see where you are, depending on type of connection. So with 1 megabyte per second, it will take you 30,000 years to transfer 100 petabytes. Obviously not something that you want to do. So we have a tool that is very easy to use. It's data transfer service. So here, when I open my console, I have in the menu the transfer. So I can create this transfer from the console, and I can use another Google Cloud Storage bucket as a source of the transfer. So that means I can schedule ongoing transfer from one storage bucket into another if I want to, or I can schedule S3 bucket, and I can just specify the S3 location and I can schedule that transfer, or I can just provide a list of object URLs. And you could see that when Spotify decided to migrate from AWS S3 to GCS, they have about 30 million songs. Each song has about 9 different transcodings. So that was total of roughly 3 petabytes of data in 1.5 billion files. So they scheduled this transfer just like I showed you. It was that simple in the console. And after a few weeks, the 3 petabytes were transferred, and only 144 files were not transferred for some reason. So they had to repeat that operation one more time to transfer remaining 144 files. But overall, it was very smooth, and you can do that very easily. And then once you transfer, you can switch over and use, again, S3 XML compatible API. Now, if you don't use S3, if you have your data on-prem, you could use the transfer appliance. Google has transfer appliance where you can store roughly half a petabyte of uncompressed data, or with compression up to 1 petabyte of data on that appliance, and then you can load that with your own data, send it to Google, mail it or send it through truck or whatever. We will unpack, unload it, and put it into your GCP account, and then wipe that appliance clean, and you can repeat that. So this is certainly not something that you want to do every day, because it's just not convenient to do these kinds of things every day. But if you have to do it, let's say for one time migrating your data center, or maybe do it once a month, that might be a very convenient way to do things if you don't have access to the high bandwidth network. And speaking of the high bandwidth network, so there are several options how you can connect to Google Cloud. There's always a choice to connect directly through the public internet, and then you can enable VPN over the public internet. And then you can also connect directly, either directly to Google through the peering or private interconnect. So that's either L3 or L2 connection. Or you can connect through partners, also L3 or L3 connection, if you don't have access to one of the 100 peering points that Google has. And these connections could be 10 gigabit, and then you can bundle them up. So if you want to have, let's say, 100 gigabit per second, you'll just have 10 of those connections, and you can use that for uploading the data. And once you have the connection set up, then from on-prem, you could use JSUtil to upload massive amounts of data. There is a parallel upload option, and you can copy files back and forth between the Google Cloud Storage or on-prem and transfer your data and files and databases and whatever content from on-prem into the Google Cloud. So here are some examples of customers. Mike, is that you?
Yeah,
okay.
Sorry. Yeah.
It seems like the airplane is taking off.
Yeah, sorry, I'm going to turn it off now.
Okay, turn. No, I think it got better right before you turned it off. But we have multiple different customers using Google Cloud Storage for various reasons. Some of them use it for streaming of video and music, like you could see Vimeo, Spotify. Some would use it for website hosting and multimedia and distribution for genomics research. So next thing I wanted to do was to dig into some of those specific use cases and explain how Google Cloud Storage could be used there.
Sure, sure. Anthony, let me ask, you've been watching the questions. Are we covering them, do you think, in chat, or do you want to cover any now before we move on to use cases?
Yes, I think there are a few questions just kind of across making decisions between these different tiers. And I think that Roman will be covering that in a little bit right after this section. So I think we can just kind of table those questions till that section.
Yeah, if we don't cover it, we can talk about it at the end.
Awesome.
Sounds good. Yeah, thank you. All right, so let's talk about the web apps and how could you use the GCS for web apps. So there are several different use cases, and this is not an exhaustive list by no means, just some ideas. So first you could replace your FTP, because FTP, it is a proven technology, but it's a bit of a hassle to set it up, and then whenever you store the data, it's definitely not encrypted by default. It's FTPS, SFTP, encrypted in transit. With GCS, you could easily avoid all of that setup cost and running your own server, because you get encryption at rest, you get encryption and transfer. So I think that's a really good use case, even though it is a super simple one. For websites, you can also use GCS for user download staging. So for example, if your users are requesting some kind of reports or some software downloads or other things, you can just generate and put that content on GCS and then share that link with those users. And if it has to be secure, you can sign that link and only share it with that particular user. So only he that user or she has the download link, for example. Now, I will cover static web content mobile use case on the next few charts. So traditionally, the architecture for web application is that you have a front load balancer, and then you have a bunch of app servers, perhaps Tomcat server with servlet engine, and then you have some data in a database, maybe MySQL on the back end, and then some static data like HTML, images, CSS, JavaScript. Now, if you have a high volume website, this very quickly becomes a problem, because obviously you have no choice but to go through Tomcat server for all the dynamic data, but all of your HTMLs and images and CSS and on all of the other static content, if it flows through your Tomcat server, it basically increases the latency and it overloads your server. So you have to have more VMs, more cost. So it's not an easy, well, it's easy to scale, but you have to pay a lot for all of that compute power, where you don't have to. The way to simplify it is separate your static content, put it on cloud storage, perhaps multi-regional, depending on the user demographics. If they're always in the same region, then you could use just regional, but if they're worldwide, then multi-regional is a good choice. Then in the load balancer, with just a single click, enable CDN, and all of a sudden, all of that traffic is bypassing your Tomcat server. So you reduce your cost dramatically, because you don't pay for all that compute to serve static data, and you reduce latency without rewriting the application, because it's all done through URL changes. So the application stays the same, your users are happy, and the application runs much faster at much lower cost. The other use case is a mobile integration. So Firebase is a Google tool with a number of really interesting services that lets you build mobile applications for iOS and Android. And we have a SDK integration with Firebase. So you can see the Google Cloud Storage integration at the console level, as well as you can use the SDK and in just a few lines allow users to download and upload their data from all of those mobile devices. So you get all of those benefits of encryption and reliability with Google Cloud Storage. So that's definitely a very, very popular use case. Another typical use case is a backup, and there are roughly 3 different flavors. So one is just a normal backup, where you have massive amounts of data on-prem, and maybe you don't necessarily want to pay for all the tape and disk to store your backups. So you could use Google Cloud Storage, in this case maybe Nearline, to store the backup data to reduce your cost. Another one is, if in addition to reducing the cost, you also want to put your data in a geographically remote location for disaster recovery, perhaps 1,000 miles away, you can use GCS for that as well. And then another one is archival. So for instance, you might have some compliance requirements if you're a financial company, or you perhaps do some media transcoding, and you keep the transcoded media on a multi-regional or regional storage, but maybe you don't want to get rid of all of the originals. So you could put all of the originals on a cold line so that you can have them just in case if you need it. And speaking of a regular backup, so the disk and tape, they have some of the benefits, but in general, disk is a very high cost solution compared to the cloud storage, where tape, it costs are low, but it requires significant personnel costs, and the reliability of tape is not that great. So cloud is actually a much better choice for backup. And how do you use backup into the cloud? If you go to this URL that I show here, you see there are many, many partners that Google has for backup solutions. So the way that it works, and I'll just pick one example, perhaps Veritas as an example. So if you're using Veritas today or any of these other backup solutions, it works more or less the same way. Whenever you pick the destination target for the backup, like the storage, instead of just using the local storage facility, you just usually click on the drop-down box in the menu in that cloud software or command line selection, and you just direct your backup destination into the Google Cloud Storage. So you'll have to create the project on Google Cloud Storage, and then you provide the service account to your backup software, and now, voila, without any extra work, your cloud is now your backup. So this is very easy use case. Whenever you want to restore, it's the same thing. You just point to specific bucket in Google Cloud Storage, and your favorite backup solution will pull the data from there. So it's a very easy way to get started. It really doesn't require any specialized skills. It's really just a normal way you used to do backup. Now, we did talk about differences. So Nearline is good choice for backup when you don't expect to access it more than once every 30 days roughly, and we talked about SLA, and we talked about the consistent API, so they all work the same way. Where ColdLine is more suited for longer term storage, like roughly access the data probably no more than once a year.
Right? Yeah, okay, great, Roman, thanks. Now, I think a lot of customers are going to probably have situations where they've, they're not all in. So let's talk a bit about how customers in that situation, can work. So yeah, there you go, hybrid cloud.
Yeah. So you're right that there are many cases when you have some of the data on-prem, and then for whatever reason, maybe the data set is too large and you don't want to pay the capital cost of investing into petabytes of storage on-prem, and maybe some of the data moves back and forth between multiple offices that you have worldwide. So the technical use case, it's not a business use case, I call it hybrid file system, and that is normally done with Google Cloud Storage Regional plus partner solutions. So again, if you go to this link, we have several partners like Avir, NetApp, and Dell EMC, and many others who build a gateway hybrid file system using Google Cloud Storage and your on-prem storage in a single packaged, that you access it as a virtually single logical storage file system, where in reality, depending on how hot the data is, they will move it back and forth and move it through the life cycle, keeping it perhaps on local SSD files first, and then as the data is aging and you don't access it very often, it can push it off into HDD and eventually into Google Cloud Storage. And just to give you a flavor how this works, so with Avere, one of the partners that Google has for this kind of hybrid cloud storage, you could see on the bottom part both the compute and storage that you might have on-prem, front-ended by the Avere appliance, which is a physical appliance, and then it provides a single logical view on your file system to all of the on-prem compute. And in the background, it can utilize different on-prem storage facilities as well as Google Cloud Storage in the cloud at different storage tiers. And the same thing if you were running the workload compute on Google Cloud, then you can use the virtual Avere appliance, and the same way that virtual appliance will be backed up and will map its data either into the Google Cloud Storage or into on-prem. So you have this hybrid where you can access that data either from on-prem or from the cloud itself. And it all looks to you logically consistent, so you don't have to worry about doing that yourself. So that's a very powerful. Now that hybrid cloud storage, it can be used for all of the use cases, like in big data, for example. So talking about big data, there are sub-use cases, machine learning, log processing, where you can decide that maybe from the on-prem or from the cloud, and multiple clouds, if you have Azure workloads or AWS or GCP workloads, you can be streaming or batch shipping your logs into GCS for further processing and analytics. There are genomics use cases, ETL workloads where you could use Google Cloud Storage for extract, transform, and load staging kind of environment. So that's very popular. So it's surprising how versatile cloud storage is. So take an example at, for instance, Hadoop, the managed Hadoop that we provide, we call it Cloud Data Proc. So you can certainly use HDFS as a file system for the Hadoop workload, but you can also replace it with Google Cloud Storage. So you could see it's fairly easy to do. You just replace that URL for the source file. But there are several benefits to that, to using Google Cloud Storage. So for one, the data that you have in Google Cloud Storage is persistent across restarts of your Hadoop cluster, where with HDFS, it's not. Then you also save time. You don't have to transfer the data into HDFS from somewhere else if you keep it on Google Cloud Storage. And then the startup of time of the cluster is also much, much faster because you don't have to wait for all of the nodes to become live. GCS is always up and running and ready. The data is encrypted. You don't have to manage it. And you can also share the data with other users. So there are many benefits, and there are quite a number of users who decided that the Hadoop on Google Cloud, the data proc, they're using GCS to store the data. Another example, genomics. So Broad Institute, for instance, they're using Google Cloud Storage extensively. And on some days, they have a really good connection to Google Cloud in terms of the bandwidth. So in some days, they transfer more than 100 terabytes of data per day into Google Cloud Storage. And they have several petabytes total, multi-petabyte storage of genomics data. And then they're not only using it themselves because it's on Google Cloud Storage, they can easily share it with other institutions and researchers across the world in a secure fashion. So the data is encrypted and protected. So it makes it easy for them to do the processing of that data, and they also use Google Compute and Google Genomics. But it makes it easy to collaborate that data with no capital outlay. So that you only pay for what you use because that's the way it works in cloud. And there's also a really good use case for media, right? Mike, I know you're a fan of media.
Absolutely.
Yeah.
Yeah.
So for media, there are sub-use cases, right? There's transcoding, which is what Spotify did, transforming, in their case, format of those audio recordings into multiple different transcodings depending on the mobile device of the end user. There is rendering, which is done, for instance, by the animation studios or special effects, where you have to render every single frame of that movie, and media streaming, like audio and video streaming, like Vimeo and Spotify. So for rendering, we have a reference architecture where you could do that rendering from a local compute and connect it to the cloud, and you can also burst into the cloud. And again, I'm using the VIR because it's one of the popular solutions, and it's used by quite a few companies out there that do rendering, so that you could do burst into the cloud from on-prem, and the data is being shifted automatically, and you can collaborate multiple different studios worldwide working, or offices of the same studio company can work on the same set of data, sharing that through the cloud. So remember, the regions in Google Cloud, they're all connected by private network. So the speed of transfer is very, very quick. And it's more secure and cheaper than transferring the data over the public internet, and faster as well. So the VIR is one of the several solutions that could be used for that rendering workload, whether you render completely in the cloud or on-prem, bridging into the cloud as a hybrid. And transcoding is another example as well, where we have our own Envato transcoding solution for complete media lifecycle as a Google product. You might want to check it out. And we also have a number of transcoding partners that can take in pretty much any existing format that is known to man today of media, and transcode it into whatever other output format. And one of the destinations, as is in persistent disks, they can also write it out into the Google Cloud storage. And then you can move it between different tiers of storage. Now, as far as streaming the media, Spotify originally started with S3 back many years ago, and then they started using CDN with S3 because it's expensive to always pull data from the cloud. So CDN makes it faster and cheaper. And then eventually, they just recently moved into Google Cloud Storage, and Google Cloud Storage is integrated with a number of CDN providers. So one of the things that Spotify really liked was that Google Cloud Storage is very well integrated with CDN providers, and it has very, very low latency, and it's optimized to work with a number of CDN providers. And some of these providers, like Fastly, for instance, they can actually ship logs real time back into Google Cloud Storage or BigQuery for analytics.
Great, Roman. That's you've given like a whirlwind tour here of all sorts of things. Yeah, a lot to take in, but a lot of good coverage. Can we kind of go back and recap again, and then see if we do have any questions?
Yeah, while you are looking for questions, I'd say there are 4 classes of storage that we discussed, and hopefully I gave you examples of what are the use cases for different classes of storage, like nearline and cold line for archival and backup and disaster recovery, long-term storage, where regional is usually for data processing like machine learning, big data, analytics, transcoding, rendering, and multi-regional is for media distribution and media streaming usually. And then again, you can define automatic lifecycle policy. So if the object has been created and it's just sitting there without access, or it's aged, you can automatically move it between these classes of storage. Want to also point out that you can get started with Google Cloud Platform. So you could just log in with your Gmail and get $300 credit for 12 months, and you can use this $300 credit on compute, on storage, on machine learning, on any services that we have on Google Cloud Storage. So it's a very flexible offer. We don't limit you to any specific service. You can use those $300 on anything you like that you see on GCP. There's also an excellent podcast that you may want to subscribe to. I know when I'm driving to and from work or run on the trail, I love to listen to podcasts, and this is one of my very favorite podcasts. There's also competitive comparison, Google Cloud Platform comparison to AWS and Azure that you can find on the website. And finally, we have pricing calculators. So if you're interested to see how much it will cost you to store a certain amount of data or run certain number of compute cores and gigabytes of memory, you can get all of that on that pricing calculator.
Great, Roman. Thank you, so much for putting this together and taking us through it. Anthony, do we have, I know there were a couple coming early on, or there are some additional questions or anything that we didn't cover?
Yeah, I mean, I think that we were able to handle most of the questions in the chat. There is, I think covering the different types of patterns across cold line was really useful. So no, I think we're all set. Again, Roman and Mike, great job. I think that there's a lot to know about GCS, and it seems to be prevalent across several different types of use cases, which I think we covered in pretty good depth today. So awesome job.
Great,
right.
great. Thank you, everyone. Thank you.
Thank you.
All right, take care.